So this little video here is just to give you an introduction to how machines interact with our lives, how things have changed over the last 70 or 80 years or even 100 years, and just give you a general overview of it before we get into the actual computational type details. You will be given an assignment, a lab report to do where you'll be going out into the world or in your home, whatever, and finding other examples of such transitions. But in a sense, a machine is simply a device that allows for a transformation of energy from one type to another. It could be electrical to rotational, it could be translational to another, and even if it's in the same direction, the machine can increase the force, which of course makes it very useful to humans as we do our work. In the picture you see a sailing ship. This is a modern version of one, but all those sails, the acres of canvas so to speak in the old days, often would be wet and had to be hauled into position, and the only resource they had was ropes. And so they needed to improve their ability to lift, to pull, even with strong men and a number of people. And this was the block and tackle, which you now see here. I'm sure at different times in your time you've seen this device, and we'll talk about how this actually helps us improve, so that you pull on the string that goes off to the left with a, say, 1 Newton of force. In this case, you'd probably get 6 Newtons of force at the ring if you're lifting. And we'll talk about the equations and how that rolls out. The ships of the 1800s and in the early 1900s were overwhelmingly based on wind and sail. And so you had this highly complex set of riggings that the captains and the officers would have to understand. If you notice on this particular example, the netting, those are ladders, and the men would climb up those nettings to the yard arms to release the sails. And remember, the boat is rocking in the seas. It is a very disconcerting business. You can see here some tie-offs. Notice how neat everything is kept. You don't want your ropes to tangle just at the time when you really need them to do something. So this type of thing, the ship itself at times may have been soiled if it was a whaler or something like that, but you'd still do everything you could to keep your ropes and the main things that you use in order. So the sails could be furled as they are here, or unfurled, and as you can see, the men are standing just on basic ropes across. Now this is a modern picture, so they may well have a safety belt of some kind that you can't see, but in the old days there'd be nothing like that. And so you'd be climbing up in the rain or weather, it could be cold, whatever, and do what you're told. And so it was quite a different kind of workplace. This is a true picture here, I believe in Maine at the turn of the century. You can see that what they call the forests of mass. The giant white pine trees of Ontario and of the eastern United States, many of them ended up as the mast for these large sailing ships. And of course, the problem with wind is that you are, in many ways, no matter how skilled the sailors, you are at the mercy of the weather. Here is an example off the coast of North Carolina. The Outer Banks is a sandbar kind of thing that's about 30 miles off to sea. Every black dot you see is a wreck, and so the boats will be swept ashore and run up against it. Remember that in the old days there were no lifeboats and no life preservers, so if the ship sank or came in trouble, you went down with it. It would only be if you were clinging to some flotsam. When steam showed up finally, in the bottom of the ship you had large boilers and the men who shoveled the coal into these boilers were known as a black gang. And this has nothing to do with race, it's to do with the color everybody is after about 10 minutes. Nobody worked harder and was paid less to do this. And so they're shoveling the coal into the boilers to produce the steam to run the boat. By the 1940s, things had improved primarily because the boats were bigger. And you have the stokers who are shoveling the coal in, and the trimmers who bring the coal from the bunker by wheelbarrow to the front of the boiler. And again, there's only two temperatures down here, hot and hotter, in the base of these ships, especially when the ships are sailing in warmer waters. There was a very typical arrangement. This is an example of a Liberty ship from World War II, which you have these reciprocating piston type engines, and you have your coal bunkers and your boilers to provide steam for it. And these pistons would be they could easily be 4 or 5 feet in diameter, and they would push down the rods, which would then turn the propeller. And so it was a fairly straightforward system. But of course, steam leaks and all kinds of other ways, getting in the ways of the works was pretty dangerous business. And it was more confined than you might think. Here's a true restored ship, and you see the rods here to going to the cam. So from the center bottom of the image is the shaft, probably the propeller shaft that this thing is turning, and the pistons are above. And so it's pretty confined, and you can see there's absolutely no protections for the workers. If you go by and your clothing catches something like that, I mean, it's all over. If we go now to a modern container ship or cruise ship engine room, you see the large diesels and how clean everything is and how safe in comparison things are with hand railings and all the rest of it. And because in the end, the modern perspective is that it is better for everyone involved, including the company, to run things in a more responsible way. One of the things we learned a long time ago was the ability of water pressure to raise and lower things, and a lock is an example of it. There is no pump in a lock. All you have to do is open valves. There's a valve on the low side and on the high side. If the ship in this example is going from low to high, you go in, close the doors, let the water in from upstream, which on its own will fill the lock up to the level without doing anything else. When the lock is properly filled, you just open the door and the boat sails on. And this hydraulic capability that you can see here is that if we put a force F, as you can see on the left, the smaller cylinder, down on it, it will produce a pressure that's in the fluid, and this pressure will be the same everywhere. But because the area of the larger cylinder is greater, you will get a greater force. It just won't move as far. Now this can be expanded to presses and other devices that were discovered in around the 1700s, where you could take the lever on the right there and pump smaller, easy amounts for an average person to push into the chamber, and that would push ultimately this vise together with much, much greater force than you could by hand. And now that we can motorize this, we can use this pumping of fluid to move things all over the place. And here's a simple example of a device called a directional valve. If the valve is set in the left portion, there is no flow at all, which is usually the general case. Usually the left block is in the center. When you then pull the lever one way, the flow from A will go to the tank, the flow from B will go to pressure. If you let it go the other way, then it will not cross over, and B will go to the tank, as an example in the diagram, and A goes to the pressure. This is a directional valve. You see these things on tractors and other devices where the levers, when you pull the lever, that actually pushes the cartridge back and forth and will determine which way the fluid flows. This particular example here is usually for raising and lowering the loader and tipping the bucket. If we go ahead here now to a real tractor on a farm, in a moment when that gets there, you can see here the same type of levers. Again, one to raise and lower, and the metal cartridge you see there is inside of that is where this slider is going, and the hoses simply take the hydraulic fluid to and from that directional valve. And that's what that's what's happening when the operator is pulling on the levers in a mechanical device. Obviously today many things are computerized, but that's the way it was for a long time. Here is a representative tractor. You can see the hydraulic rams, both at the top where the hoses are connected and down on the arms. And these will push the loader up, and then the other ones will tip the loader. You can see whether the arms are double acting because they'll have valves on both, or piping on both ends. This would allow it to exert force, either pushing or pulling, depending on what you've selected. Hydraulic presses can, of course, become much larger in static positions. You can see here looking at about 3,000 tons or something in the neighborhood of 6 million pounds. So phenomenal ability to press and shape things in a factory type environment. And of course, this was all in the old days. We used something called a steam hammer, which I will show you in a later picture coming up. When we look at our ability to build things, the moving of earth and digging was very compromised until after the war. This is what is known as a steam shovel. In the back of this is a boiler. You can see the chimney, and there'd be a small steam engine in there, and it would pull with a winch the different cables, and this would allow for this device to do some moving of dirt. But we compare that today to the modern power shovel, which is driven by a diesel engine. The forces exerted are much greater. You have the hydraulic rams in the same places. There's 3 sets you can see here, and as well as rotation of the entire cab and trench assembly. These devices work a lot faster and can exert a much greater force because they're not driven by cables, so they have a great amount of ability. And the ability to move material before the war especially was really limited to railroads, because the trucks, as you can see here in the 1930s, were very small. You know, if you take 2 cows or you take maybe 1,000 pounds of dirt or something like that, that was about all they could handle. So you needed a lot of them, and they were in comparison expensive. The old saying in the old days was that people were cheap and machines were expensive. Today it's the opposite. And we see now an extreme case of a power shovel for strip mining, and the circled object in the center is a person. In this case, they're moving vast quantities of dirt because there's not that much ore in each bucket. So then you have to move a lot of material to get things going. Excuse me. I'd like to move on to some workplace safety issues, just to give you a taste of the way things used to be. Here are examples in the mines at the turn of the century, and this is in Pennsylvania, but it could have been anywhere, of boys picking out the clinkers. So as the material comes from the mine, they're going to throw the rocks that are not properly with adequate amount of ore in them. And the supervisor's there with a cane. Now, it'll depend on the place, but I'm quite sure the cane was used if a young person didn't do their work properly. You can see it here as another example again, and these young guys are 7, 8, 9, 10 years old. And you can see the openings, so you can imagine how cold it would be. This is up in the head tower of the mine, so they're up above the ground. And again, if a boy fell into the works and got caught up in the machinery, they didn't turn it off until the end of the day, because you wouldn't want to lose any money just for one kid getting mangled in the machinery. Here's, of course, mules in the coal mines, and again, the lighting system was a flare. We all know that coal mines have methane gas in them, so there's, again, a whole new bunch of ways to die in these situations. Again, there's no ability to protect them from their the breathing of things, and you only mined where the seam was, so you didn't mine more rock that was useless to make a better place for the miners. So you can see here the miners having to contort themselves, and this is a powered train, so if he doesn't duck at the proper time, he will hit the beams above him. And this was the way things were at the time. Again, most of these images are taken from before the war, although I have a feeling this one might be in the late 1940s. If we move ahead then to today here, where you're up at the face, you have all air-driven or hydraulic equipment. The miner has a health protection, a non-combustible light, hearing protection, and all the rest of it. So first, the machinery is far more effective than the men, and secondly, the idea is that the men go home at the end of the day in the same physical conditions when they left, save being a bit tired. If we move on to many other examples of industries, here's one around the turn of the century, although it was done before that. In the woolen mills in England especially, but certainly in the United States as well, you have many little spools of thread called bobbins that have to be changed on a regular basis as these things knit together. And young boys would be hired because they were nimble, and they would be run around and put these uh, bobbins, so to speak, and so they were known as bobbin boys. And of course, you notice there's no guards on any of the belts or machinery, so again, it wasn't much of imagination to see a young boy getting caught. In the old plants, the machines themselves did not have motors in them. They were driven by overhead pulley system. So in the plant, you'd have a large boiler and steam engine apparatus, maybe more than one, that would run the spindle. And you can see the spindle from dropping down from the top center of this image. And it would spin. And as they wanted to run one of their machines, they just pull a lever, tighten the belt, and it would work. Notice the ladies' dresses are very narrow and that their hair is done up because you wouldn't want to get caught in the machinery. Same mechanism here for a sawmill. This is a museum piece, but it is historic. Again, the large set of wheels along the ceiling driven by the steam engine somewhere in the plant. And then if you want to run the different machines, you simply pull a lever and the steam engine power will drive this device for you. This was the norm pretty much until after World War II. Even in the meat business, you see here a sausage kitchen in Germany, and my father remembers working in one of these in the 1930s. And you can see all the machinery there, all driven by the sealing spindle system. And the machines on the right are powered. The machines on the left, of course, are only driven by hand because they don't require it. So it was that was the way it was done. When the war was finished and we standardized electrical power, the machinery began to get their own electrical motors. Certainly in the 40s and 50s, there would still be plants left over that were driven in this system. When you worked in these towns, the smokestacks and the smoke was sort of an indication of your progress. People lived nearby and walked to work. You were in many ways living in the buildings owned by the company. So it was a lifelong existence in many cases of not much more. Many miners ended up owing money by the end of their careers because you had to buy your food and materials from the store. Here's the steam hammer. So the material they're pounding in the center there is red hot. And the thing above that machine is driven by a steam engine, and it will come up and down very fast with tremendous force. And you can imagine that would be shards and sparks going everywhere. Notice that the men are not wearing eye protection, and that they're turning this device all very close by, and there's an easy 100 ways to get hurt here. Here's a steel mill where you're pouring from the ladle into the molds, the molten steel. You can see the man off to the left is wearing little protection and certainly nothing for respiration. One of the greatest ways to get injured in a steel plant in the early part of the century, or the later part of the 19th century rather, was to get splashed. And I'll let you think about that. We also see, for example, in the sense of cranes, even though we're dealing with much, much greater force now, we still use this notion of block and tackle. And the reason that we do this is that that keeps the cables thinner, so they bend easier. And the only reason, and then we strand the cables as well, so when they go around a corner, they don't have the rigidity of a bar. And when you do this, of course, you have to grease them, which is why all cables are greased, because these fibers will rub against each other. And when you do that properly, and the radius is not too small, is a very, very effective way to use cables to do so. You can see here, I believe this is the Golden Gate Bridge in San Francisco, built in the late 1930s. They're bringing a part up, and you can see the two men are simply riding the crane. So you stand right on the actual hook or something nearby. Actually, there's three men there, pardon me. And as it goes up, their hands are in the cable, letting the cable slide through. And you're 100 feet above the tidal currents of San Francisco Harbor, something that today would not be tolerated. These are in the 1950s pictures of New York City skyscrapers. Those I-beams are probably 8 inches wide. And of course, up in New York is a port, so you're going to get winds off the ocean. And so it doesn't matter how good your balance is, you can still end up finding a way to get into trouble. I think these were probably stunts for the camera, to be honest with you, but even still, it was obviously something that they did, and then without any safety harness. This is an older picture taken back in the 1930s. A number of examples of high iron workers doing daring things. And I think this ended up in Life magazine or something like that. But you can see, I'm sure, that the men were not the least bit put off by this, because it was pretty much a natural occasion. The beams were put together by rivets, and you would pound them in with sledgehammers. And if you got a shard in the eye, the foreman would come along with a magnet, take the piece out of your eye until you get back to work. If we look here in the meat industry, this is in the early part of the 20th century. In Chicago, they're splitting hogs here, but notice how the ceiling is made out of wood and that there's flaking paint all over that could easily fall in. That type of thing was very common. Also, I'm sure this is a staged picture because their coats are very clean here, which I doubt they would be under normal conditions. If we contrast this with modern work in the meat industry, you could see here in a processing plant, the workers have helmets on. That's primarily because there's hooks and things in the ceiling that could fall. Hair nets, gloves, aprons, and all the rest of it. No real physical contact with the product. And of course, this is long before we had the epidemic. And the idea here is to vastly limit. And of course, this entire room that they're working in is refrigerated as well. If we move on to the auto industry, you can see the Henry Ford assembly line here from probably the mid-1920s. This was a good job in those days. It paid fairly well compared to many, but it was also known for its brutality. Ford was hugely anti-union, as was his son Edsel, and so there was foremen and so forth were noted for their violence towards people on the lines in those days. It was a tricky place to work. Here's how things had modified at Ford into the 1960s. Here they're making the Mustang, the late 60s, early 70s. You can see it's a more contemporary look to it. The men are wearing whatever clothes they brought to work that day. It's not there's no outfit or uniform, but you can still see the assembly line idea, which of course is required for the production levels. And then we can go to a very modern case, the Mercedes-Benz factory in Germany, where you see the cars coming out, and notice how clean the entire facility is. And there's actually tours being conducted here, and they have to follow a certain route so they don't get too close to what is going on, because we don't want the production system affected by the tour. So here's some basic things. I hope you learn a little bit about how things were and how they are, and now we'll get into the details. Thank you for watching.